Good morning, good afternoon. Thank you for having me here. Serverless Belfast, first time here in Belfast as well as in Serverless event. So, how many of you, before that, how many of you are familiar with Google Cloud? Oh, cool, so many. So you're familiar with these logos. So today I'll be walking you through a journey of a specific customer story where I have been working with them for the consulting and engagement, and how they leverage serverless and move to the cloud from a complex legacy system to give a digital pulse to the physical stores. So here we are not talking about any online business, but this is a customer who runs real physical stores. Sorry, I'm running asynchronous here, so the control is from there. Okay, so my name is Sijohn, and I'm based out of Stockholm, Sweden. I work for a company called Aclarity Tech, and we do consulting as well as product development, especially in retail space. And I'm a GD, Google Developer Expert in cloud. And here is my LinkedIn profile. Sorry, I forgot to add the QR code. All right, so let's set the stage. What we are talking about, the story centers around a customer who is into retail convenience store, which is run in a franchisee model, and they operate with full physical stores spread across 7 countries, all 4 in Nordics and 3 in Baltics. So you can imagine this scale, especially when it comes to the physical store, it brings that much of complexity with the diverse regions, personal preferences, then local regulations in each country. And then adding to that, another set of complexity was like, the company was grown more inorganically by mergers and acquisitions. So you can imagine like different company, different software stack, and all kind of complexities. And their existing tech stack from a central organization was really not built to handle these kind of complexities. So this was the heart of the mess. So I just want to picturize it in a very simple way. They had a history of, it's a 100-year-old company. So they have a history of adopting to the various best-of-the-breed softwares during those times. They were really good at that time. No debate in that. But then, over a period of time, this added to the mess of the landscape because point of sale data, the transaction data coming to one tower, they are sitting in a silo. Then the finance data, then the partner delivery data, the inventory data, all this data was sitting in their own silos or unconnected towers where it was really difficult to connect together and then get a single version of the truth, and that too in a real time. You can get it, but then using bad jobs in the night and then failures from that. So this was the major challenge we were facing from a base layer. So what was the vision? The vision was really clear. We needed to build a digital twin. When you say digital twin, a twin or a replica of the physical store in cloud or in a digital world. I won't say cloud, in a digital world. So we wanted to create that pulse. Essentially, whatever happens in the store, those things we need to replicate, and we need an enriched reflection of each store in the digital presence. And so that we can analyze those things, those events, those data in real time, like in an online business when you have an online business with a website, right? So there the advantage is that you get the pulse immediately to analyze in real time. But with a physical store, that is a big challenge. So that was the vision. So, and we needed to build this not by focusing on core infrastructure and expensive and complicated teams to manage that. We wanted to do it in a very agile and DevOps way. And this is where serverless became the obvious choice when the customer embarked on this journey. And it was not easy, like all the projects. But then the turning point in this modernization was that we decided that we will go with a services first approach, or we call it as API first approach. This wasn't about ripping and replacing all the things what was existing at once. No, that is impossible. It was building a strong foundation with a well-defined interface to interconnect these disparate systems. And then the goal was to create a services platform and a unified data platform to break down the silos. And in the journey to build that, make it as simple and easy to manage, that's where the cloud and the serverless came into the picture. And on top of that, we wanted to make it like event-driven. We want to get real-time pulse, immediate pulse from whatever is happening in the store. And this journey, we started back in 2021 during the pandemic time when the businesses in the store was very low because it was physical store, so you can imagine how it was during the pandemic time. And especially it was a convenience chain, so people were not coming out. So we started this journey in 2021. I would say that in 2 years, we reached a maturity level in our services platform, because in the API first approach, we say about maturity levels, right? Like level 1 to level 5. We reached a maturity level of 3 by 2 years, in 2 years' time, on bringing up the core services into the platform. So to those of you who doesn't know about the API first approach, what is it doing is that it prioritizes APIs as the beginning of the software development process, positioning APIs as the first-class citizens in the software development chain. So API first organization always instead of treating the development as the first priority, we develop the interfaces first, we define those things, and then jump into the development part. So this is just a deviation from the topic, but this is what we were trying to achieve. Then, of course, in this forum, I don't have to introduce what is serverless or why we went for serverless, but still emphasizing on the importance of serverless. It is to bring the simplicity to drive the autonomy part. So basically, if you see this curve, so there is a very little gap between what you need, which is the blue line, the bottom one, and what you pay for, which is the serverless usage part. So this is a very simple depiction of why we do serverless. And as we all know, serverless scales automatic, and then the invisible infrastructure part, which the vendor is managing, the cloud provider is managing. And this is the perfect use case for event-driven architecture, where we need real-time insights on the sales and all those kind of happenings, or the pulse, what is happening in the stores. This is the core components. I know that this is not a good diagram, but sorry for that. This is the core component of our serverless architecture, and this is a very simplified version. And like I said in the beginning, this is fully on Google Cloud. And so obviously all the components are from Google Cloud. Starting from the left part, this is where our external and the internal systems start interacting. And in Google Cloud concept, we divide this into virtual projects so that they don't, this is the virtual boundary between the projects. So we have the proxies project, services project, and the data lake. And we have many more, but for the simplicity, I have put only the very few things. I want to highlight few of the components here, not all. We have an API gateway, which is fully managed for the API management part. And then comes Cloud Run, which is basically the heart of the compute part. Cloud Run manages containers as service. And then we have PubSub, which is the message bus. And that takes the whole publishing subscription model in our architecture. Then we have the Firestore, which is our NoSQL database, which is mainly used for the operational part and then the fast lookups things, along with Redis memstore, which is not there in the picture. And then there is another core component, which is actually a virtual component, I would say, which is the event arc, which is basically driving all the event-driven architecture. And event arc is the event model in Google Cloud, basically built on top of the open standard cloud events. And then at the end, we have the BigQuery, which is the fully managed serverless data warehouse engine. Then we also use Cloud Functions, which you can actually relate to Cloud Run, but that is actually doing function as a service, and Cloud Run is mostly for container as a service. Recently, they moved Cloud Functions, which is a bit on the technical part. We will come to that later. For example, in this scenario, why we are using Cloud Functions in an analytical layer is one use case is that there are certain functions or there are certain functionalities in the, when you write a SQL query, you need to do some kind of business logic. So it becomes so complicated sometimes to get that or go to an API and get the data. So in the BigQuery, there is an easy function, easy way to do that. It's called remote functions. In the query, you can call a function by deploying a cloud function, basically. So select star from, so in that, select the remote function from this table, it can go and call this cloud functions. So that is just an example case. So what else? So let's move forward. So let's look at the cool stuff what we have built. I have taken two use cases here. One is about the use case about our vision, the digital twin part, how we treat the physical store like an online entity. So we started doing exactly the same thing. So this is a replica of the dashboard what we give to each store. So when we say the store, because the stores are franchisee, so they are owned by different people. So every store will get this kind of dashboards. This is kind of analyzing a brick and mortar store like an online business. So we have sensors, which are like basically counters, the IoT sensors in front of the store, which can count the passerby traffic. When I say passerby traffic, the people who are passing in front of the store. Then we can analyze from that how many people are coming into the store. And then after that, how many people are buying something. So basically the average passerby traffic, then the external conversion, because only 15% of the people who are passing by is coming inside the store. Then after they come inside, okay, 75% is buying something. So these kind of data, because we are not capturing it through camera because of all regulations, it's all sensors, and then we mix this data with the real-time transaction data to analyze the internal conversion. So to do all these things, it should be real-time. Otherwise, this doesn't make any sense. So this actually gives the store owners more confidence and to try out new things, like what was the impact of this? So one of the primary impact was like they could make data-driven decisions because they are not technical people, but we are providing the data in the most cleanest way to the store owners. So they can take data-driven decisions like how should they put the layouts. I mean, there is already a planogram, but still on top of the planogram, there are, based on the stores and based on the location, sometimes the things which are to be kept on the front shelf versus which has to be kept on the cashier's desk has to be changed. So these can be easily changed by getting those kind of information in real time and based on the footfall and the engagement of the customer. Then we all are software developers, so we know about the A/B testing and how good it is. So similarly, they can also do like kind of A/B testing on their local promotions, because every time promotions is one of the key thing in the physical stores as well as in the online. But when you display promotions, how effective that promotion, they can actually derive it from these kind of data. So that was one key thing what we got from this kind of dashboards. And of course, optimized staffing level. These are small stores, but still during the peak hours, like the morning rush for the breakfast and the coffee, and the evening rush for the, if you are in Sweden, it's the Swedish fika, and then the afternoon rush for the maybe tobacco, these kind of things. So these are the things they can analyze easily using those kind of data-driven dashboards. I'd like to bring one more use case. The reason why I'm taking these use cases are because these were like small ideas. And in this organization, there is a concept called, I know that in most of the organizations, it should be having something like this, but there is a concept like an idea board. And people come up with a lot of new ideas, the teams come up with new ideas, but most of those ideas just sit there. It never goes to production. This idea, especially, this was an idea come from the idea board. And I would say that because of the flexibility or the easiness of getting things done easy with the serverless ecosystem, these ideas came into light in weeks time, literally. This is a simple example of ice cream predictions. This is a very impactful, but it's a classic problem for almost all the retailers. Either stock too less, in the case of ice cream, based on the weather. If it is a cold day, they stock too much and fill the freezers. If it is a hot day, they stock too less and unhappy customers. So what we did, the solution was blend the data, basically we blend the historical sales data with the historical weather data, and then we analyze the pattern, like how was the ice cream sales. And later on, this was moved out of ice cream to almost all the products, like for example, the sandwiches and coffee. But how the sales was impacting based on all these historical data, then what we did was like, we forecasted based on the weather forecast we fetch from the public APIs. So based on that, then the stores will get a replenishing or an inventory management kind of, how much they should stock, basically. For example, in this ice cream case. And later on, this was even enriched by bringing in data from the common events happening in the city. If it is a store which is in the middle of the city and there is a parade happening at this time, then we analyze how many events were happening in the history and then analyze that sales data with the historical data plus the weather data, combining, and then we predict based on that as well. And all these things are done because of the power of the data. And then again, we don't need to provision anything. We don't need to manage the scaling requirements, these kind of things. And on top of this, all these ML models, even BigQuery is the analytics serverless engine in Google Cloud. It offers BigQuery ML services, which is again serverless. And all these models were built so quickly without thinking about the overhead of a GPU or a TPU by just using the BigQuery ML, and then the BigQuery ML can be easily used in a SQL. So that's how the things are evolving so fast. Again, the impact of this use case, I don't need to explain it too much, but almost like 15 to 20% reduction in the wastage. So this was a great number, and this was a great example and the success story of taking an idea from the idea board. And then, of course, the shelf availability improved a lot. Then automated replenishment suggestions and inventory management become smarter. So so now I'm stopping about the business part. So we are all engineers, at least majority here. So we will talk a little bit about the two main components in this whole architecture. One is the data part, and one is the compute part. And in the data, this is the BigQuery is the core of the unified data platform. And if you take a 10,000 feet view, this is how it looks. If you define that in the 4 quadrants, I would like to do like a collect quadrant where the data is being channelized and collected into the the analytics engine. And these are the supporting serverless products in Google Cloud, helping to inject things into the analytic engine. And then coming into the processing part, it is mostly, I would say in the old school way, it is ELT, and now it is like ETL. Now it is ELT. We load it and then transform it to enrich those data. And initially we used DBT, and now we are migrating things to Dataform, which is again a Google Cloud product itself. And there we use cloud functions. One use case was the remote functions, what I said. And schedule queries, again, it's like a cron job, which is fully managed and serverless. And after that, we analyze the data, and during the analysis part, it's mainly we need to have event-driven things. So we use PubSub there. And again, BigQuery also completely support all the event-driven things using EventArc, and then the PubSub can listen to that. And finally, the activation layer is where all this, the visualization comes, and then now we are doing things using those data. I mean, activating that data into the the AI models, like where the Vertex AI is the platform in Google Cloud where you use, the AI foundations. And then we exposes this data. I mean, that is a new project we are doing right now. We expose the data, which is enriched and processed through APIs again. And this data become a part of data monetization, because this is historically the main revenue was the retail business. But now an alternate income source itself is data. Selling monetizing this data back to the suppliers of products. Like for example, Coca-Cola or Pepsi, they want this data actually. I mean, how much is their sales? I mean, this is another way to an alternate income actually. Again, why serverless in big data analytics? This is a simple depiction because the essence is that in the traditional way of doing things, most of the time we consume is monitoring, tuning, and provisioning the resources. But when it comes to the serverless, if you look at the right side, we focus only on the analysis and insights. No headache about provisioning or like monitoring things. Of course, there is a cost involved in that. Here, in this case, we don't need to think about, okay, how many times we do select star from this table. You don't worry about that, but in that world, there is that. I'm not talking about that challenges part. That's a totally different session altogether. This is another perspective. I won't go deep into this topic, but this is another perspective of how the BigQuery acts as a serverless analytics platform, not just the unified data platform. Because if you see here, this is a complete ecosystem where your data and AI things come together actually. From applications to predictions to analytics to visualization, everything. And if you take a role of with every user, from a application developer to data engineer to a data scientist to a business user, everyone is having a tool to use in this whole ecosystem to work with the data. So that's what this diagram and this whole ecosystem depicts. And what the journey of this customer proves is that the way they shift the mentality, the way we treat data now as a product brings a very data-driven culture and accelerates that realization of what is the value logged in this data actually. Now we are treating data as a product rather than treating just as a data. So that's what the whole this diagram depicts. I'd like to take you through a couple of new features in BigQuery where we are trying to use it in different places. So bear with me if you are not too technical, but this is simple to understand. One is, of course, the Gemini in BigQuery, which I have not kept as a slide here. Then one is the new features is the BigQuery pipe syntax. And what's the beauty of this is, like, if you take the old school SQL query, select from, where, group by, having. If you mess this order, you are broken. Your query is broken. But with the pipe syntax, it is more aligned to the way, maybe like not the old school SQL developers, because they are quite used to this format. But when you're a new business user or a business analyst, okay, I need something from my table. Like then, how will I visualize? Okay, from my table, I need to aggregate something and count and then group by. So this is how now the new syntax actually aligning with our thoughts, the new syntax is being built. So then this order doesn't matter actually, because if you can put the where country equal to US here or even to the top, it doesn't matter. Like if you see the other one, both things work. So the new syntax, this makes the chaining of the things in the way how we think about the things. Another example here is that it gives you the interoperability also, because this is the old school of old way of writing the query, but you can actually mix between the old way and the new way. So that means like if you are supposed to rewrite something and then you want to plug in something inside, you can actually mix the things without rewriting everything. Another feature which is related to the AI thing is like the AI.forecast function in BigQuery. And more than the function, what I want to tell you here is that the way how they bring serverless into everything. Because in the old school ways, we have to train the model. This is, for example, this is a model which is called Times FM, a state-of-the-art time series forecasting model actually. And this will allow you to highly, bring accurate time series forecasting for millions of data in seconds. So if you look at the syntax here we are telling the query to use this model. This is a real query actually. We are telling the model to use this Times FM 2.0 model, which is already a pre-trained model. We don't need to train it. And we are telling like, okay, this is my data column, data, and this is my existing timestamp column. Do a projection for 30 days. So it's as simple as that and using this model. So then it will give you the results on your current data set. So that's how the power of serverless brings to the table, because otherwise in the old way of doing things, we have to train the model, we have to feed the model, then you have to test the model. Of course, in this also, we need to test the output, but this is how simple it is to do things. Now let's move the focus into the compute part. In Google Cloud, like in other clouds, there are multiple offerings. The main two offerings for the compute is the Cloud Functions and the Cloud Run. Cloud Functions, earlier it was called the Gen 1 Cloud Functions. Now they moved to Gen 2, which is the Cloud Run Functions. And it is, like the name says, it's a function as a service. You deploy a function as a source code and then execute directly. One example was our BigQuery remote functions. Or you can write any functions for that matter. And Cloud Run, it is basically deploy containerized applications as services. And Cloud Run actually can run in two modes. We will see that. One is, it can run as a service, which will respond to web request and event-arc-based events. And then we have the Cloud Run jobs, which is basically used to run code that performs longer jobs. Because Cloud Run service will time out after a period of time, like 60 minutes is the max, I think. If you want to run longer jobs, like for example, your data migration job or long-running batch PDF generations or those kind of things, you can use Cloud Run jobs. So, and then Cloud Run comes with a very generous free tier of 2 million requests per month. So my time is over. So I have few more things, but it's not of very relevant things. But to conclude, these are the what we are doing with the customer at this moment is like like the first example I said about data monetization, we are monetizing the data. Then we are working on the sustainability goals, both on the compute platform, the sustainability part, and then on their products. Then democratization of data by bringing in more of this natural language to SQL and things like that, bringing more people into the data layer to talk to the data. And of course, the new sales channel, like bringing the delivery partners like Uber, Foodora, etc. Yep. Thank you.